Hello and welcome to the demonstration video for my final project in data and machine learning for artistic practice. I have built a corpus-based concatenative synthesis-based sound space exploration system, which consists of 3 components, which I'm going to showcase in this video, but first we will take a look at the groundwork. So it all starts with audio data, and you can see here my sample library, and I'm just going to play you a few samples so we can see what the system is actually going to work with. So if we have a look at one of the samples here, a simple clap, or we can have some drum loops. So these are all WAV audio files, so raw uncompressed audio files, and the system is going to read a selection of them and then construct a sound space from them. So if we start up the system, which is best done by the terminal, then we can see the user interface. And it says database not loaded. Click to load because I've deleted the old database and we're gonna reinitialize the whole system now. So if we click here, another window will open which points to my sample folder here, but you can change it to whatever folder you have your samples in. And those are the same folders we saw before, so I'm just gonna select a few of them. Let's say the first 5. And then if I click open, we can see in the terminal output that it's analyzing all the WAV files contained in the folders that I just selected. And what it does is it extracts audio features from them, like pitch, loudness, spectral centroids, like the brightness of the sound, and spectral flux, so how the spectrum of the sound develops over time, and classifies them for very small grains of sounds. These grains are approximately 20 or 40 milliseconds long. And once it has compiled them all, it stores all this extracted information in a database, in an SQLite database file, so that we can then traverse this huge sound space we just created out of a few hundred samples. So now it says loaded. And now we have to start our agent. So that happens in the second terminal window. The agent is written in Python and it's a deep reinforcement learning agent. So if we execute Python, the interactive agent v5.py, it will start up the agent. And you can see in the other terminal window, it has something has changed because the agent says hi to the backend, and then the backend says, okay, I've just received some parameters from this agent. I'm going to create a trajectory from these reinforcement learning parameters that I just got from the reinforcement learning agent. So we can listen to this in the backend if we just hit spacebar or click play. And it sounds pretty boring and similar and homogeneous because the initial parameters of the reinforcement learning agent are just 132 float values that are all set to 0.5. So in order to make this more interesting, we can hit explore, and then the agent will go to a kind of random point in this sound space and then create a trajectory through it. So through these dimensions that we have created in the analysis before, and then we can get something like this. So this is a kind of random sound that comes from a kind of random set of parameters. So the parameters map to these grains, and you can hear the grains are all super short and blend into each other kind of. But now we only have this static trajectory, which is kind of interesting, but also kind of boring. So we want to adjust it to our needs. And that's where this part of the interface comes in. We have the minus and plus, and then the downwards and upwards triangle. So the minus and plus give the agent feedback on a singular decision it has made, where one decision kind of contains all the parameters. So if we give it a minus here, then it will change, it will kind of realize that the last change it has done to all its parameters was not too good and we want it to be something else. And if we give it a plus, then the agent will learn that the change that it has done to the parameters is good and that it should continue like centering in on that location. And then the downwards and upwards triangles are zone feedback. They are basically stronger versions of the above. So if we give it an upper triangle, it learns to really focus on the current zone where it's at in the latent space, in the sound space. And the downwards triangle tells it to go to another region and explore other things. And then if we hit explore, we just reset it to a different one. So all of this happens when we click run agent, which loops the current trajectory, so we get constant feedback. And then we can give it feedback. So we can press minus if we don't like it. And we have to give quite a lot of feedback. And if we really don't like it, we can give a negative zone feedback. And after a few of those, the sound will start to change. As you can hear, there's slight changes happening in the sound already. And the further we go down or give it negative feedback, the more it will change. And then once we find something we like, we can instead give positive feedback to tell the agent to center or like to solidify its current selection. So if we give positive feedback, it will learn to stay in the current environment. And then once we're happy, we can just press the agent running button again, and it will stop. And then the current trajectory will be in the buffer. So if we hit play, we will get basically the output where we arrived. And then we can do a few other things. We can hit L to loop it. And then if we are happy with this, we can use the audio and do whatever with it. But another interesting thing to do is to prime the agent with user audio. That basically means instead of initializing the agent with a random trajectory through the sound space, which is what happens if we click explore, we record a sound, and that sound is then converted into grains, and then the agent gets the trajectory through the space that closest resembles the grains from the recorded audio. And we can do some really interesting things with this. So if we hit reset, which basically resets everything, so both the backend, this application, and the agent, everything is set back to normal. And if we then hit record, it will use the computer microphone. So if I hit record and then I sing a note, for example, ooh, it will prime the agent with that instead, which sounds like this. And it's very quiet. And then I can go from here, or I can prime it with more percussive sounds, or mix them together, which sounds like this. And then if I have this and I have primed the agent with that, it's basically set in this trajectory of the space. And if we run it then, we can explore from there, which is super interesting because we can start with something that kind of sounds like what we give it and then explore from there. That sounds pretty good. But then if we want to go somewhere else, we can hear it changing again. And it starts to sound cool. Okay, so let's hear what we created. And that is basically the functionality of this system. I'm just gonna talk a little bit about the web interface, and for that I'm going to switch to my mobile phone. So I will have a web server running on my computer, which is also connected to the agent and the backend. But then you can change and interact with the agent from your mobile phone, which is super interesting if you think about a performance scenario where that could be embedded not only in a mobile phone, but basically into any device which is OSC capable, which is quite a few devices. And I will be right back from my phone. So after we've seen what we can do with the user interface and the agent on the computer, I just want to show you the mobile interface. So I've started the web server on my browser, on my computer, on my notebook, and I'm on the same network here on my mobile phone. So I will go to the IP address of my computer. So that's 192.168.100. And then the server that I have running will serve this web page to my phone, which runs in Safari. You might have to press get accelerometer permissions if it doesn't prompt you, but I've given them already. And you can see that the accelerometer changes the position of this little ball circle thingy at the bottom. So if I tilt my phone up and down, the circle moves, and it has still loaded the same trajectory we just created, so I can play it back. And this is basically just a user interface, so I can do the same things here. I can record, I can give feedback to the agent, I can run and pause and unpause the agent, and I can explore. But the interesting bit about this interface is connected to the circle, because what the circle does is as soon as I press the area of the circle, it lights up. And as I tilt my phone with my thumb pressed down, it just takes a certain point from the trajectory, so the height of the circle area in which the circle moves is mapped to the whole trajectory. And as I press down and move my phone, I move through the trajectory. So if I'm all the way at the bottom, it starts, and then as I tilt, it goes through. And that's interesting because if I take my phone now and I press down and I explore some movements, I can create some sounds from the trajectory. And based on the audio data that we have in the trajectory, you can create quite interesting sounds sometimes. So you can create percussive sounds, and depending on how you prime the trajectory, you can basically build a small little instrument that you can then play with your phone. And I think that's it from me for this time. Thank you for listening and watching, and I hope you have fun playing around with it.